This is part one of a five-part series on file access. Let's review the basic code for a simple console database which we will use to demonstrate sequential file access, random file access, and object file access implementing serializable. We will use this basic shell code with each different example to examine the differences between writing unencapsulated globals, single objects, and arrays of objects utilizing different methods. By reusing this example in subsequent videos, we can shorten the learning curve and concentrate solely on the topic of file access as we examine the different methods available to us. We've been discussing different types of file access: random binary file access, sequential Unicode or ASCII file access, class serialization, and object file access. And I'm going to use the same example. I just coded sort of a quick and dirty, hopefully brief program utilizing both arrays and single objects so that we can examine, 3 or 4 different types of file access. We'll look at how to save objects, in a single object in a file, how to save an entire array of objects to a file, different things like that. But we'll use the same program here in the console to illustrate each different type of file access. So let me just run through this real quick and kind of give you a sort of a preliminary breakdown of the shell, the program shell, so then we can just concentrate on the code that has to do with file access. All right, so first off, we have a class of object here, the person class. All right, and it's standalone right now. It eventually should be an ADT for a class hierarchy. This are going to become a more sophisticated database. Right now, we're just going to use it as it is. Okay, just a person class, no inheritance, not extending anything. The constructor is just going to call initialize, which is going to give it initial values. And this will sort of be our base object here. And then we have these public accessor methods, the gets and the sets, to get and set this private data. So nothing out of the ordinary there, but just things that we're already used to as far as a typical class, a standard class. Okay, so that's a person class object. All right, so again, let's look at the shell first, and then we'll come back and talk about the imports we're using and the file access. Okay, so if I go through here, I have some globals, and the first global here is an array. Okay, it's an array of person objects, and we just call it people because it's multiple persons. We have a scanner object. You could just as easily use a line number reader if you want to apply the try and the catch. You could use a J-option pane, show input dialog, whatever you want to use there. We have a constant or final integer value here, max people, which is the size of the array. And we want to make that final because once we create, the array of objects, we want to be careful and watch things like null pointers or array index out of bounds errors and things. So we don't really want that to be changeable. So we decided to make that final. And then we have just a public static count. All of these are public and static. And all of our functions are public and static. Static being that we don't have to instantiate or create an instance of this class to be able to use the functions or the data. All right, they exist out there, by themselves, so to speak. So these are our globals. All right, and now let's go to our main function. Here's our main menu. So what happens? Main gets called automatically as soon as we run the program. There are no command line arguments that are being passed in. I haven't coded it to accept any, but we declare a string called choice, and that'll be used with our menu to get what the player wants or what the user wants to do. We need to build our array. We declared it up here, but now we've got to actually build it. All right, and it's an array of person type objects. And here's our final, max people, so 100 in this case. Then we have to populate the array once we build it. So we populate the array, we just create a for loop, we go through and we instantiate a new person in every single element there. So now we've populated our array. All right, and now here's our main menu. It's just a while true loop. We decided to use a string. We could have used a character, but if we did and they typed more than a single character, which sometimes people are prone to do, instead of just Q or A, they'll actually type out the word quit, then you'd have problems because it would overflow the size of the variable. Remember, characters are a 1 byte value. So if they typed in quit instead of Q, then that's 4 bytes versus 1, and that would cause looping, kind of repetition errors, and depending on what you're doing, it can even crash your program. So the only reason that we're using a string here is we can still process it as a character. Remember that we couldn't switch, like down here where I'm switching, I couldn't switch in a whole string, but I can get a single character. But this way it just enables it to deal with the possibility that the user might type in more than one character. So we don't really care what comes after the first character. That's all we're looking at, and both the switch and the while true loop. But this gives us the ability to deal with it, hopefully, a little bit more gracefully. So we take the string, we get the first character there, as long as it's not equal to q. Q is a sentinel value in the while true loop. Here are our menu choices. We have to display them for the user. We use our scanner object to take input and store it in our string. And just in case they hit enter and it's empty, we don't want to call to lowercase or do anything if it's empty. Otherwise, we'll get a null object, a null pointer error, and it can cause our program to crash. So if it is empty and if they just hit enter by accident or something, we're just going to set it to be a space, so that way choice has a value, some value. Then we can call to lowercase without any fear, and that just makes it a little bit more friendly for the user. They don't have to worry about whether it's uppercase or lowercase. Ultimately, we just convert it to lowercase. And that means we only have to provide one case for each letter or option in our switch statement. Remember, again, we can't switch on a whole string, but we can take a single character. So we use the char@ function. Here are our choices, and from here we simply call different functions. Okay? So, first function we'll take a look at, let's look at add person. Let me scroll down, and actually I'll just go over here to the navigator pane. We'll go to add person. And add person, we call count records, and all count records does is it starts out, it loops and goes through and counts all of the person objects in the array that don't have a value of -1. Well, if you remember, in our person class, an initial value for ID was -1, a non-meaningful value. All right, so we're kind of using that as null. And so if it's not -1, then it's something that we've stored data in. It's something that has a meaningful, purposeful data in it. But if it is -1, we're not concerned with it, so we're not going to count it. All right, so we're just counting all that. And if it's not -1, we'll increment counter, and that way we can count up all of the actual objects that we're storing person data in, actual objects that we've used in the array. Okay, so it'll just say how many there are in the database, and then it returns that integer value, all right, the count, so that way we can sequence the next ID number to be, if we had 5 objects in the database, then the next one needs to be 6, or if we only had 3, the next one needs to be 4, or if we had 97, the next one should be 98, and so forth. So that's what count records does, and when it gets done, it spits out an integer, returns it to count. We want to make sure that it's less than max people. We don't want to let them add a person if they've exceeded the maximum number. So, in other words, max people -1. Remember, there's that off by 1 thing. So yes, it's 100 elements, but it's indexed from 0 to 99, not from 1 to 100. So we're subtracting 1 there. And then we're just going to add a new person, and, we're going to actually manipulate things with the 0 value, starting at the 0 index value. That's what the computer likes. That's what arrays like. But for the end user, we'll tack on 1 just to make it a little bit more user-friendly, because humans like to start at 1. They don't always like to start at 0. Also, we have to modify the precedence here with the parentheses. If I took that away, it would just think that this was concatenation. So hypothetically, say that count had a value of 5. It would actually just concatenate it and say 5-1 and display 51 instead of 6. So we have to wrap parentheses around it to modify the precedence. So instead of concatenating, it knows to add the 1-2 count first, and then say if it were 5, it makes it 6, and then it displays that and concatenates it with the string literal over here on this side. Okay, and then of course, otherwise, if we've used up all of the available space in the database, we'll just display hey database full. Can I add more records? We'd have to go and remove a person and then delete some records. Okay. All right. So let's go back to main. And inside main. All right, that covers adding a person. Now, what about removing a person? We'll go to remove a person. Remove a person calls select person, okay? And select person, in this case, is, it just handles the validation, making sure that we choose numbers that are within the valid range, making sure that we, actually, use a number and not type in banana or some craziness like that. So it handles the validation and everything in our little database example. So let's go take a look at that. And also, actually, let me back up a little bit. Let me go back to add person real quick. I never even finished that, did I? Well, once we do this, we figure out what the count is, okay, we're going to call edit person. We're going to pass count in. All right, so that's, if it were 5, we had 5 records, now it's going to be 6 or whatever. We're going to pass count in and call edit person. And what does that do? Well, edit person is overloaded, okay? There's two edit persons, and they're overloaded. Remember that when you override, it's a vertical relationship. They're at different levels of inheritance. But when you overload, you're at the same level of inheritance. In this case, we're all inside the function, so we're overloading. What does it mean? Functions with the same name, but they have different arguments or list of parameters. So this edit person takes no arguments, and this edit person takes an integer as an argument. And in this case, what we're calling from add person is this version, right? The overloaded version that does take an integer as an argument right here. And what does it do? It calls edit person dialog, all right? And then edit person here calls select person, and that does some validation and so forth. Okay, so let's go over select person real quick, and then the next thing we want to look at is the edit person dialog. So we're going to look at select person because we use that a lot of different places in the program. What does select person do? It just takes care of the validation. It's going to count the records like we did before. It's got an integer here and a string that we can use. Here's our menu, our choices. It's going to display the currently selected record's name. Okay, and we're going to start out with the first record in the array. All right, so record 1, which remember is indexed as 0 in the array. But we'll make it user-friendly here. Just add a 1, tack a 1 on so it looks like a 1 there. Then we're going to take that very first element in the array. We're going to call name on the person object and get the person's name, whoever they might be. And now just a little bit of some helpful functions here. We can navigate back and forth in the records, forwards or backwards. We can go to the next record and move forward. We can go to the previous record and move backwards. We can call view to display all of the data on a selected item, and we can quit and exit and go back to the previous menu, or whatever called this function selected person from. So those are our choices. We have to take input. Same thing. We have to check, make sure it's not empty. If so, give it a value, convert it to lowercase. Now I wanted to do a little bit more than I could do with a switch. A switch is nice and convenient and compact. You can pack a lot more code into it. But sometimes you can't always use a switch when you want to do a little bit more sophisticated logic. So all of this we could do with a switch right here. If char was in or p, next or previous, what do we do? But I didn't want to have to generate a case for every single digit, and not to mention it'll just been in this example, or in this case, it would have actually been a lot longer to use a switch statement. A lot of you guys wondering, well, I thought you always use a switch with a menu. Well, you can also use if and else. And so here's, if we choose the next record, then what's going to happen? Well, we need to do a little bit of testing here. We need to make sure that, however many objects from the database, we don't want to move on to objects that don't exist or that haven't been, initialized or haven't stored useful data yet. So we're going to look at the value of count. If there's 5 objects, now remember it's indexed to 0, so we're going to subtract 1. And if num is less than count minus 1, all right, so then in this case we'll move on to the next record. Otherwise we're at the last record. We're going to say no more people. You can't go any further. Okay, so that's one possibility. If we move too far forward by entering next. I almost said click. We're not using a JFrame, but now if we enter P for previous, we have the opposite possibility, and we have to do a little bit of testing there. So if what happens if num is greater than 0? So we have to make sure that before we decrement, because if it happens to be 0 when we decrement, we get -1. Well, we don't want that. That's not a meaningful value. So we're just doing the opposite, but this way we can do next and previous records right there. Okay, and I'm using else if. I could have gone if all the way down, but I wouldn't want to. I wouldn't want to bother testing or evaluating all of the other options if one of these conditions is met. That might, save us a little bit of, who knows, a CPU cycle or two, or, a smidgen of memory. But so we're just using else if all the way down. Now, if you view, that'll, call view person, which is a currently selected person, and we'll look at that in a moment. But that just goes through and displays all of the data on that person. Okay, and then here, if they choose to quit, then we'll simply exit. Otherwise, we got through all the other possible choices. So the only thing left is they would have typed in a number and wanted to select a specific record. And if that's the case, then we're going to go through here and we need to convert the string that they type in into numerical data, into an integer format. And then because of the off by 1 or the fence post, we're just going to decrement it. In other words, they're wanting to display record 1. Well, that's fine. To the human, it's 1, but to the computer, it's 0 because we start at 0. So we'll decrement it or subtract 1 there. Now let's test the range. Let's make sure that num minus, if it's num minus 1 is less than 0 or num is greater than max people minus 1 either way, then it's too small or too big. Either way, we'll just tell them, hey, it's outside of the valid range, and we'll just default it to 0, the first record. All right, that's the first possibility. The next possibility, in this case, if they choose a number, let's say that there's only 49 records, in the array that have been initialized and set up with data, and they choose to try to access record 50. In this case, it'll say, hey, there's no person at that location. And again, just defaults to the first record. And then, of course, there's the possibility that they type in, banana pancakes or some weird thing and not a number at all, in which case we have to catch a number format exception and be able to handle that as well. Finally, when we get done, we simply return the value of num. All right, so all of that just takes care of our validation. Okay. So let's go back to edit person here. All right, so they select that, and then we call edit person dialog. And edit person dialog just goes through, and it's just gonna, all of this class data here, we have to, give the user the means to set that data on a person object. So we need to call all these accessor methods here. And that's all this function's doing. So it's going to display the previous value. So like the first time through, it would just display these initial values here. Not meaningful values, but at least they're initialized so we don't get, null issues and things like that. If they just hit enter, if it's empty, then it would remain unchanged. But if it's not empty and they enter a new value, we'll replace the old value with the new value via the accessor method, from the person class. So that's all we're doing. The strings are pretty basic. The only thing we have to watch is, like for things like age, it's an integer, not a string. So we have to call integer parse int, all right? And then things like size and weight, they're not strings, they're doubles. So we have to call double parse double. But same thing, we're displaying the old value. Do they want to change it? If they enter a different value, we'll save the new value. If they just hit enter, we'll keep the old value. We won't change anything or do anything. So they have the ability to opt out if they want. Simplistic, but it works. Same thing here. Weight, we have to do double parse double because it's not a string. And the rest of these, occupation, location, references, it's just string data. So pretty straightforward, pretty simple. Same thing, we're just, getting input from our scanner object, and we're setting it as a string via the accessor function or the accessor method. And finally, when we get done, we call viewPerson. Well, this utilized all the sets, so what do you think viewPerson does? Right, it utilizes all the gets. And all this does is we just, just in case we check to make sure that the object's not null, we wouldn't want to call get and try to get a value on an object that had not been initialized or null. If we're careful, we'll make sure this never happens, but it's kind of a good idea to maybe always add that a little bit of a, sort of a if wrapper there just to check. Anyway, we just call the gets, and again, there's that off by 1 issue. So, we're indexing at 0 to 99, but for the human who's going to be viewing this, the user, it'll appear as 1 through 100, okay? And we're just calling all of the data and displaying the data from within viewPerson, okay? So let's go all the way back to main, and I'll just use the navigator pane here to kind of warp to main. All right, so we've gone over add a person, remove a person, edit a person, and let's see, display a person. We haven't really done that, but that works with view person. So let's go over display a person. Display a person, display a person, display a person right here. All right, here's display a person. Okay, and what does display a person do? Again, it calls select person. That lets the person choose, and then once they make their choice, it goes through and we can walk, kind of waltz through the code here. But once they've chosen the person, here's another while true loop, and then we want to, make sure it's not, -1. Make sure that it's an actual object, and then if it is, we're going to go call view person. And view person, remember, it displays all that data. Again, I'll go back and show you view person. Just calls the accessor methods and displays all that data. Okay. Otherwise, no person to display at this position. That's if they select, some invalid record or something. And then we're just going to give them a little sub-menu here. So once they're locked in this function inside this while true loop, they can just kind of browse backwards and forwards, next and previous, from different records in the console. Again, if we really wanted to make this useful, we'd probably put it in a JFrame or a JApplet, and they'd have buttons to click on and fields that they could input information in. But to simplify it so that I was trying to hopefully utilize as little code as possible, I just made this a quick console app. All right, so we go through there, and we're going to take our input via scanner object. Again, we have to make sure it's not empty. If it is, give it a value, convert it to lowercase. And then all we're going to do is, for the menu choices here, next and previous, the very same thing we did in, select person. All right, in select person, remember we had to check and make sure we didn't go past the last valid record or before the first valid record. And then if so, we'd increment or decrement. Well, that's all we're doing here with N and P. And then Q will just exit, okay? So that covers everything up to search person. Let me go back to main here. We've covered all of the functions except for search, okay? And let's cover that real quick, and then we can finally talk about what we want to talk about, which is file access. So looking at the search function, we have two strings here, choice and search item. This will be used for the menu choice of what to search for, and this will be utilized here as a string value, either parsed and converted to an integer or double, or as a string to look for a particular field item or field data within a person class object. Okay, and we'll just use these numbers here for integer parse_int or double parse double, whatever. So we have a menu here. What do you want to search for based on the field data that's in the person class? Remember, here's all our data. Name, occupation, location, references, ID, age, size, and weight. All right, what do you want to search for? ID, name, age, size, weight, occupation, location, references, or we can quit and exit the menu. Have to take our input via scanner object. Let's check, make sure that it's not empty. If it is, give it a value. Otherwise, we just crash and get a null object error if we tried to call to lowercase or do something with choice. So as long as we make sure it's not empty, we can convert it all to lowercase, makes it a little more user-friendly. Go through, remember that we can't switch on a whole string, but we can switch on a single character. So we use the char@ function. However, using a string, once again, makes it a little bit more forgiving in case they were to type in the whole word instead of just the first character. Go through, we'll switch on it, and then whatever they choose, we have to have a case for each item. So just at a glance, you can see all the cases there for all of the menu choices up here. And then what happens? If they're searching for ID, we take input via the scanner. We have to parse it, convert it to an integer, because remember, that always comes in as string data. So we convert it to an integer, and then we're going to go through the array and look for any item that matches, its ID. Get ID returns an integer, what we parsed or what we converted, what the user was looking for. And if we find it, we'll call viewPerson, passing in the index or subscript value of x, which will take care of displaying that person. Okay? And in case they type in banana pancakes, we have to catch that. Okay? It's a number format exception. And it's the same if they choose size, only now we have to do double parse double, and we also have to catch a number format exception. Again, what if they type in some craziness instead of an actual number? And also for weight, double parse double. We have to catch a number format exception in case they type in some craziness. Now for the rest of these items, they're pretty easy and straightforward because it's just a string data. If they're looking for a name, we just take it in, we store it in search item, and I'm just going to use the function contains. We could also use equals, the function equals, but that would mean it would have to be an exact match. And let's say the person's name is John Smith. If I use contains instead of equals, then they only have to type in John or Smith and they'll get search results. I guess if you really wanted to get more elaborate with this, you could add lots of submenus saying, do you want to make it case sensitive, yes or no? Do you want to look for an exact phrase match or just part of a phrase, and blah blah blah. We could add a lot more, but then that would just take more time and end up being more code. And if I were going to do that, by golly, I'd certainly make at least a graphical interface for it, a JFrame or a JApplet form or something. So yes, we could do a lot more with that, but we're just going to use contains, and that way if it just contains a substring, anything in that field that matches whatever they type in, then it'll display the results. And it could be multiple records. If there's 3 records with Smith in the name field, then those 3 records would be displayed, in our for loop. And the same thing for all of our other strings. I have to bypass age and size and weight. But when I get down to occupation and location and references, same thing. We're using contains and we're just matching it up against the field data in the person class object. Okay, so that's pretty straightforward. So you can fast forward through this part if this is pretty basic, or if not, if you need to get a good understanding of the program shell before we get into file access, you might want to kind of rewind a little bit or pause. But I just wanted to get through all of that, so now we can focus on the topic at hand, which is different types of file access. In this case, saving items sequentially, single objects sequentially, and entire arrays of objects. Let's run the shell once to see how it works. So let's run it and kind of walk through it a little bit. And in this case, if we want to display a person, right now there's nobody in the database. All right, record 1 is none. And if I were to go, we'll test some of our validation. No more people. I can go no further. Next, because we haven't added anybody yet. If I go previous, at the beginning of array, can go no further. So just sort of our validation there. And I can't display anybody. Again, if I want to go previous, at the beginning of the array, if I want to go next. All right, so we're just testing our validation. Let's test adding a person. And right, notice in this case, there are 0 people in the database. Adding a new person with ID 1 in our array. So Charles, Germany. We'll look at the age, 42. Size, weight, I'd rather not say, but and let's see, current value of occupation or occupation none. I'm an adventurer. Location in the Kingdom of Hyrule. And references. Lincoln Midna will vouch for me. All right, so I've added that, and let's say I'm going to add. I'll just add a couple other people here. So notice that put one person in the database. All right, I'm going to add. So now it says there's one person in the database. I'm adding a new person with ID 2, and I'm just going to do XYZ real quick. I'll go with the default. It's empty, but the bulletproofing works. In this case, instead of crashing, it just defaults it or changes it and leaves it as a default value. Occupation, location, and references, I'll just leave those as none. I'm going to add another person. Now there are 2 people in the database, and the next ID therefore is 3. That was X. This will be Y. And I'm just going to do 3, 4, and 5 respectively, and then Y, just as an illustration. Add another person. There are 3 in the database. Now there's 4. I'm going to do Z, and I'll do 1, 2, 3, and Z, Z, Z. All right. So now there are 4 objects or people in the database. Now let's look at displaying a person. Okay, and notice that it displays the person. It calls view person when we're done, editing. But if I wanted to go through and cycle through the records, I could, in this case, it tells me at the beginning of the array, first record, Charles, Germany. I could go next, X, Y, Z, and now I'm at the end of the array. Okay, so I'm going to go previous. There I am again, and I could view that current object. In this case, that's the current object, and I'm going to quit. And that will throw me into, that allowed me to select the current person object. So here I am. And now I can just cycle through the records, X, Y, and Z, or I can go through previous records. All right, so I'm just trying to give you a breakdown of how the program shell works. And then we'll just use the same shell, and hopefully that will shorten the learning curve. If you understand what's going on here with the arrays and these functions, then all you really have to worry about in the future is how we change or modify the type of file access, whether it's sequential, Unicode ASCII, whether it's random binary, whether it's object serialization, whatever. That's all we'll be changing. All of this will be the same, so to speak. Okay. If I wanted to edit a person, I could go through and let's say that I'll choose 3 there. Okay. So 3 happens to be Y. And then let me go ahead and quit. Out of the selection menu, value for name is Y, a new value for name. Okay, name remains unchanged if I just hit enter. Okay, and let me make the age 10. So new value is 10, size I'll make 5. I'll leave weight unchanged. Occupation, Bard. Okay, and location, Daytona. And references, Mario. Okay, and then if I wanted to display that info, let me go through and, alright, there's Y is selected. Okay, and there's the, the new data has been saved, and the old data that we didn't change has been preserved, as you can see. Okay, so let's see, that covers add a person, edit a person, display a person. Let's look at remove a person, and let's look at search for a person. Alright, so if I wanted to remove a person, there are currently 4 people in the database. Who do I want to remove? Let's see, let me scroll through here. There's X, there's Y, and there's Z. Let's say that I'm going to remove Z. Alright, so I could either type in 4, or since Z is currently selected, I can go ahead and quit. Exiting. You selected record 4, and then we're just going to confirm here. Are you sure you want to delete this record? And I'm just going to say yeah. Okay, person deleted. And so now if we were to call the display person, remember before it said there were 4? Now there are 3 people in the database. And again, let's test it. 2, 3, and now we come up at the end of the database. Okay. Alright, so everything's hunky-dory, copacetic, or whatever you want to call it. Alright, so that's tested everything except for search. Let's just look at the search function real quick. And if I go through search, let's search for different items. So we'll look for an ID of 2. Who was ID 2? Alright, and 2 was X. Alright, let's look for an ID of 3. Alright, and in this case, that was Y. Alright, let's look for a name. Remember, it's just contains, so I don't even have to type the whole name. Alright, I could, instead of Charles Germany, I could just type Charles, and it finds Charles Germany because that's a substring. Kind of like the old, C++ substring functions, but using contains there, and then there's my info there. And if there was more than one record with the last name of Germany, and I type that in, or the first name of Charles, or whatever, it would show all the records. Okay. I could look for age if I wanted to look for age. Look for 1. All right, nobody with an age of 1. Let me look for age, and I'll type in 42. All right, and then there's me. And we could look for occupation. Occupation, let's type in Bard. Alright, and then there's our Bard, alright, Y. And occupation, Adventurer. And there I am. Let's look for location. And we'll type in Daytona. Alright, and then there's Daytona. And, we've already talked a little bit about bubble sorts and sorting and things. We'll get into that later too as well. But just some of the basic search functionality is here. Just real quick, I'll add another person with the same name value. Or let's throw a couple of people in there. New person. Let's see. Who are we gonna add here? I'll add my daughter there. All right. And let's see, I don't know, 3.5 maybe, okay. And let me add, let's see, we'll add somebody else here. Add one more record, we'll make 5 here. And, and, Plum and High Rule, and there. Okay, so let's go ahead and do a search real quick, and let's say we're going to look for name. All right, so I look for Germany, and notice this time it listed 3 records because there's our for loop, right? So Charles Germany, Sarah Germany, and Jacob Germany. Okay, so I'm going to do this. I'll do this as a separate clip or video. So that part is not going to change. Okay, for the next few, like 4 or 5 examples, this program is going to be. I'm not going to change any code, not one thing, as far as how that works. So that way you only have to look at this once, or look at the code one time, and then that way we can just simply concentrate. The only part that I'm going to change, guys, is this right here. All right, whether as we do different kinds of file access, and that'll definitely shorten the learning curve. So take a little bit of time and make sure you understand how this works, and then when you understand how this works, then all we have to worry about is maybe some short clips or videos on how to take that data. The data will be the same, but how we save it is going to change, or that'll be different from video to video.